So we're going to be moving into talking about area and volume now. We left off before spring break talking about net change. You guys remember that?
And particles.
Particles, yeah.
Somewhat.
Yeah. So today we're moving into a new application for integrals, which is basically area. Specifically, we've already done that, but we're looking at area between two curves instead of just area under one curve. We're looking at the area between two curves today. After that, that'll take a couple days, and then after that, we'll move into volume stuff. Volume.
Since we're looking into areas between two curves, wouldn't you just, if they're the same shape, wouldn't you time them by 2? Or would you add them?
Well, you'll see that if that's not possible for them to be the same, because if it was the same, then they would be the same function, then there would be no space between them. Does that make sense?
Yeah.
But we'll see if we can make a simple geometry connection here, which I think you're trying to go for. So suppose I have this function here, f of x, you guys, and I have this function here, g of x.
You want to write that?
No, you don't need to write this down. But you guys agree, and I want to find the area from A to B. That blue section represents the area under F. You guys agree?
Yes.
And the red represents the area from A to B for the G function, right?
Yeah.
If I want to find the area between them, all I have to do is subtract the red area from the blue area, right? So that's it. So the trick is this, is you're going to take the function that is on top, and you're going to subtract from it the function that's on the bottom, and that's the area you're going to find. That's it. So if you want to find the area between two curves, you just subtract them. It's got to be the one on the top minus the one on the bottom. You guys don't need to write this. Let's see if you guys writing that. I'm going to have you write something a little bit better here. So, but that's the basic idea. So here you go. I'll give you a minute to copy that. All right. All right. So this is all math speak that you guys see up there, but that greater than or less than, what that means is above and below. So for instance, this f of x is greater than g of x. That means that f is the one on top and g is the one on the bottom. If you don't do it in the right order, you'll still get the same answer. It'll be negative though, because you're taking something smaller away from something bigger. Yeah. Now, a lot of times you guys are going to find actually that you're not going to be looking at a graph, so you're not going to know which one's on top. Now, how can you know? So if you do the integral and you get a negative answer, you did it backwards. But the good news is all you have to do is throw the negative away. It's the same answer.
Wait, so it's always going to be positive?
Yeah, because area is a positive. Now, let's go ahead and proceed here. So find the area bounded between the two curves. So now I just want to give you guys a big picture view of where we're going with this, but before we do, I better let you write it down. So go ahead and copy that down.
Would dash y.
So I want to give you guys a big picture view here. So what we're going to do is we're going to graph these. That one's, don't draw this, but I'm just showing you what it looks like. So that's going to be an upside down parabola. That's going to be some sort of a linear function. We're going to have to find out where they're crossing, because that's where the area gets cut off at, right? And I want to find here. So we're going to set up an integral where the parabola, which I'll call this one y1 and this one y2. The parabola is on top, so I'm going to do y1 minus y2, right? And we'll call these points here A and B. Okay, and our calculator is just going to do most of this work for us, but there's our setup, right? So,
Is there a way to solve this on paper? Or is it
yes, on Wednesday I'm going to show you guys how to do one by hand, but you'll find it's pretty intuitive, I think, but just to let you practice, we will do one. Yeah.
Yeah, like if you think of that graphically, you could, like what you just did, see that y
Yeah.
is on top of y2.
Yeah.
They're both that 0.05, and then.
Oh, good obs. That's a good point. Now, another way you could do it is once you find where they're crossing, just pick a point between where they're crossing, plug it in, whichever one's higher, that's the one on top, right? That's a lot of work. And like I said, what I would honestly do is I would just take a blind swing at it and just plug it in anyway. And if I got a negative answer, I just change it to positive.
Yeah.
Okay.
On the AP test, would it ask you? Would it be like find the area under these two curves?
Yeah, absolutely.
Yeah. Okay.
Yeah, we're gonna have a lot of FRQ questions for this stuff. So let's go ahead and start typing in our functions here. Negative x squared plus 4x plus 5. And then negative 2x plus 5. And then I'm going to go ahead and graph. And if you don't see it very well, then you're going to want to click zoom. And then number 6 for standard. And that will give you a nice normal view. Now what I want to do, like I said, is before we can do anything, I need to find out where they're intersecting, right? So how do we find out where they're intersecting? You're going to click second. You guys ready? Second, and then calc. And then number 5. Because we want to find where they're intersecting. You're going to take your little arrows and you're going to move that, you see the blinking cursor? Until you get really close to where they're crossing. And you're just going to push enter 3 times. And it tells us they cross at x equals 0. Okay?
I got x equals 1.2. Oh, you moved it.
Oh, 0.5. I got 0.5.
Yes,
Yeah.
the second one is 6 and 7.
All right, so I'm going to, we'll look and see what happened there, Nikolai, but for now, we're going to store this value, guys. So I'm going to push enter again, and then I'm going to push store, and I'm going to put alpha A.
I got 0 again.
You got it?
Yeah.
All right, so store it as alpha A, push enter, and then store alpha A. Store is right here now.
Oh, I know, but when you found 0, because I clicked enter 3 times,
Yeah.
do I just hit store? Or do I hit
No.
enter again?
After you hit enter again, and then you push store.
That makes sense.
Yeah, it actually doesn't make sense to me why it works that way, but that's how it is. So
Okay, 1, 2, 3. I got x equals 0 intersection.
enter,
Enter again.
store,
Store.
alpha A, and then enter, and you're good to go. All right, we're going to repeat those steps for the other intersection point. So here we go. Ready? Second, calc, intersect, and now we're going to go over to where the other one crosses. Just scroll over till you get there. Enter 3 times. There it is.
X equals 6.
I'm going to push enter again. Store. Oop. I forgot to push enter last time. So I kind of goofed mine up. But you guys could put store alpha B, okay?
This is 0 and 6.
Yeah.
When do you know when to put 0 and when to find that intersect?
Well, 0 is where it touches the x-axis, and intersect is where it touches, where the 2 graphs touch each other.
So if the graph is going through the x-axis, then we do 0. And if the graphs go through each other, then we do intersect?
Yes.
Okay. Because the last time we did this, like, we were doing
You're right.
0.
You're right.
Oh, is this just for when you're putting in the integral? You don't need to put in the numbers?
Exactly. And the only reason, these are easy numbers, 0 and 6. Honestly, I wouldn't even use store, but I just want to review it with you. If you got weird, funky decimals, you'd want to do store. All right, so let's go ahead and do our integral. So on your paper, guys, you should at least write down what you're going to type into your calculator. So in my calculator, here's what I'd be typing. I'm going from 0 to 6. And it's going to be x squared plus 4x plus 5. You could tell which one's on top just by looking at the picture of the graph that we had. And it's minus the one on the bottom. Now, I'm not going to simplify that. There's no point because I'm not going to do this by hand. I'm going to let the calculator do it. This is what you would write down on an FRQ to show your work. You wouldn't want to just leave it blank and put an answer.
Then you plug it in your calculator.
Now we put it in our calculator. Yeah.
Are we in read or are we
You should always be in radians, but
Very smart.
we're not doing any angles here, so it actually wouldn't matter. All right, let's go ahead and do our integral. You guys ready? Math, 9, and then it's going to be y1 minus y2. So vars y1 minus vars y2, comma x, comma a, comma b. And there's our answer. All right, that's how you find area between two curves. Now, some of you guys out there have some really cool calculators, by the way. What is yours again?
T-Inspire CX Pass.
Yours might do it. So Zach's calculator might actually, if you look it up on YouTube, way easier. Like it'll shade this region right here for you that we care about. Yep. I don't know how to do it off the top of my head. I looked it up once.
Whoa! That's advanced.
But it'll shade that for you. And it will tell you the answer without having to find those points of intersection all complicated like. So, you know, Zach, you got a good calculator. Go look up how to use it. It could save you a lot of time.
Thomas.
All right.
Got a color band.
Here's one for you. Go.
Right.
That's for you.
Thank you.
So once you guys have graphed this, if you're looking at it in standard view, it looks like it just touches it at one point. So what I would do is I would zoom in and see is that the case. I went and zoomed in and I saw that it's actually intersecting at 2 spots. So I'll let you guys know of a good window to do. All right, so guys, a good window then would be x min is 1, x max is 3, y min is 1, y max is 3. You could also just use the zoom feature where it says zoom box, and you can just zoom in on a specific part of your graph as well. But as you can tell by looking at it, they actually do intersect twice. There's a sliver of space between them, not much.
Now my thing is not working.
So guys,
Sorry, these goes all
quiet please. So I graphed it, and it comes out like this. It's really hard to see, so we zoom and it looks a little bit better. It's very tiny. Let's go ahead and see what we got here. So Luke, what are the two x values where it seems to be intersecting at? So it's going from 2 to 3. And Noah, which function is on the top? That's right. And most of you guys probably put that in under y2, right? If you did it like I like this one, y1 is y2. So if you didn't do it in the right order, you got a negative answer. But you know you're going to get the same answer as the rest of us. You just throw away the negative if you did it backwards. All right, minus the other one, which is 6 over x. And then from there, we type it in our calculator. And I'm getting 0.067. Okay, very small area. There wasn't much between them. It was almost tangent to each other, right? All right, so that's the basic idea. How do you find area between two curves? Is you subtract the area of one and the area of the other, and what's left is the area between them. I got 2 questions. Let me start with David. Go ahead, Dave.
Are we ever going to do this calculator? And if
Yes.
we are, we're doing systems, right?
Yes, very good. And that's Wednesday. Good insight.
Just because you're smart, everybody else. How do we know 6 over x and y2?
Because it's the one. So on our calculator, this is 6 over x. This was 5 minus x. So the 6 over x is under the other one. So remember, the one that's on top is. All right. So let's proceed. Now, go ahead and copy down this slide really quick. Good point. Yeah. For this one, I would say that's a good guess. All right, guys. So let's take a look at it. So here's the issue. You get the issue here is that the functions switch. It goes from f of x being on top
to f of x being on the bottom, bro.
So for this one, you would do f of x minus g of x from a to b.
And then f
But
of
over
x
here-
plus g of x.
it would be what?
G
G of x minus f of x.
And you add it.
From B to
It's still
C,
the
and then
same
you
answer.
combine them, right? So you would have to switch. So a lot of times when if you have more than one point of intersections and they're crossing each other in multiple places. Now when you're doing a calculator, I'm going to show you guys something that's pretty cool, okay? Now, let's just be basic here again for a minute. Let's say f is 5, and let's say g is 3, right? What's 5 minus 3?
2.
What's this?
Are you sure about that?
But because we flipped it, what will this come out to be? It'll be positive. So basically, here's what we're going to do. Instead of adding the same thing twice, but one of them's opposite. Thank you. Here's what we can do instead. And this will work on every problem, by the way. We could just go all the way from A to C. If you do f of x minus g of x, just do the absolute value of it. Okay? Because what that's going to do is it's going to take that one that would come out negative,
And it just makes it
flips it up to a positive, right? So instead of breaking it up into two pieces, you can just take the absolute value of it. Now, I still wanted to show you this because as two of you guys have asked, are we ever going to have to do this by hand? The answer is yes. When that happens, I would not recommend doing it this way. This is nice for the calculator. You're going to have to actually just do it like this by hand, okay? All right, so let's go ahead and try one of those. Go ahead and write down example 2 there.
Jordan, you got a green letter. That means you're going home.
You got your green card?
Finally.
Now, you guys are noticing something different here, by the way. I've given you these. These are your x limits. So we're only going from negative pi over 2 to pi. You don't necessarily have to find where the graphs are connected at. So on the last problem we did, it looked like, I'll use this one. It's a little bit nicer looking. We did this one, right? Well, we stopped where they intersected, right? The way they'll word this, they find the area bounded between the curves, right? But if I wanted to, I could say, you know, find this area too, right? So you can include outside of where they cross, so you can go even further. And with trig functions in particular, you really have to have them tell you where to stop and begin because they keep crossing over and over and over again. So they tell you where to start and where to stop. Yeah.
Would we go from 3 pi over 2 to pi or pi to 3 pi over 2?
Yes, Mr. Bailey.
Go from like here to here or here to here? Like those
Yo, he's gone.
I don't know. I'm sorry. I'm just going to look at the graph, and then maybe that'll help. I'm not sure. All right.
We got how Nick broke Mr. Bailey. on
Nick
the
broke Mr. Bailey.
I was just asking.
All right. Let's go type these in really quick. And at this point, we are doing angles, Thomas. So, yes, you need to be in radians at this point.
We are doing angles.
All right. So we have negative
pi over
2 cosine x.
Oh, yeah.
And then 2 cosine x. Those are my functions. I'm not going to type in the x equals things because those are not functions. Those are limits of where my functions are going to be. So let's go ahead and look at a graph.
That's a spicy looking graph. Whoa, it looks like DNA strand.
Yes.
Math turns into organs. Organisms.
All right. Now, I'm just for fun. You don't have to do this. I'm going to zoom in on the parts that I care about. So where is negative pi over 2? That's really hard to tell. So here's what we could do to find out where negative pi over 2 is. You could just push trace and then put negative pi over 2. So just, not second trace, just trace.
Hold on, I'm trying to find pi.
Just push trace and then negative pi over 2, enter, and it will move your cursor to where that is. Okay?
Oh, I press trace again?
Just trace one time. And then if you want to find out where pi is, you could do it again. So just push trace, pi, enter, and that's there. So what I'm doing is I'm integrating from here up to here. and I want to find the area between those curves on that interval. So I'm finding the area from here up to here. So it's like a circle and a half almost, right? Huh?
Should we store it?
No. And now, if we were doing this by hand, you would have to find where they intersect, right? And then you would have to set up two separate intervals because here one function's on top and then after that it's on the bottom. But on the calculator, we're just going to take absolute value, go straight from the end to the beginning. So it's easier on the calculator, of course. So here we go. Let's go ahead and go back to our home here. We don't have to find any points of intersection this time. Even though they are intersecting, the calculator doesn't care since we're taking the absolute value. It's just going to flip them anyway and put it all together for us. So we don't need to find any points of intersection. Here we go. So math, and we're going to go to integral. We're going to type in our two functions. It was
Negative pi over 2 and
oh wait. Back up. Back up. What did I forget?
y2 minus y1 absolute value.
Absolute value. And I don't remember right now. I don't know which one was on top, but it doesn't matter because I'm taking the absolute value. So it actually doesn't matter. So I'm going to do y2 or y1 minus y2 and that is on the don't forget to close your parenthesis for the absolute value there. That is for x on the interval from negative pi over 2 to pi.
I got 12.
All right, so it sounds like we're all in agreement there.
Hold on. 0.
But once again, anytime you're doing these, you don't want to just do all the work on the calculator, not write it. You want to write down what you typed in, so at least do that. There you go. So we would say 12 is the answer. If you round to the third decimal place, it's just 12. So there you go. All right. So what did we learn from the second example? It's kind
Absolute value.
it's subtle and it's easy to miss. How do you know when to do absolute value?
When the areas, whenever there's equations switch.
If it intersects multiple times, right? Anytime it's crossing more than once, just absolute value it. Matter of fact, if you want, you can just always absolute value it, right?
Just in case.
That way, if you screw up and forget to put the right function first, you'll still get the right answer, right? So,
12.00000367.
all right.
Disney 368.
Well, guided practice. Wow. Family practice.
We can do that on the calculator.
I'm not going to make this a family practice. I'm just going to have you guys go ahead and do it. See if you guys get the answer.
Wow. What?
I know the rest of David's foul sentence. His question was, how, kind sir, do you type this into your calculator? Is that what you were going to ask?
Yes.
Okay. So how about 2 times x to the
1/3.
1/3.
2/3.
2/3. Silly crap.
2 over 3?
230 degrees.
Put that exponent in parentheses, okay?
No.
So we're going to do this problem here. What would my integral look like? I'm going from what to what?
-3 to 3.
Moises.
-3 to 2.
And what goes here?
Well, I mean, you can put whichever one you want first.
True. Because we have what? Oh, okay. I'm just going to put that, but yeah.
Minus x.
Oh. And after that, that's what you type into your calculator. And does this thing actually intersect twice or no?
Yes, it does.
It does. It's hard to tell.
Yeah, it does.
Is it?
0 gas.
Once at like around 0, when x equals 0, once around 8.
Oh, really? Okay. Okay. So, what did you get, Mario?
14.973.
Like this? Okay, so there you go. Nick, can I have you draw the graph for me? Because I don't know what it looks like.
It looks like a what?
It
I don't think
does.
you can draw a portion.
You're so-
It's a bird.
I would encourage you guys, even though you don't have to, I would encourage you to draw on your notes because you want to know what you're finding, okay? And I'm going to draw a picture for you guys of what it is that you're finding.
So it's like right here.
Ah, okay, so they do intersect twice. All right, so guys, here's what I would have you draw. Draw that little bird shape.
It's like really small.
Gotcha. All right, now check this out. We are going from Nice. We're going from -3 up to +3. But it's only the area between the curves, right? So that's this area here. And probably like right about here, right?
Yeah.
That much. And that's it. We're finding all of that. That's it. We're not finding this over here because we're stopping at 3.
Would you like us to draw the graph when we were able to have it?
I would encourage you to do it just so that you guys can, because I think you'll find that even though you can get the answer, some of you guys might have some questions about, oh, wait a minute, where is that area at on the picture? And they almost always, on these FRQs I've noticed, they always start by giving you the picture of what you're trying to find. So if you can't make the connection between your equations and the picture, you're going to have a problem. So you want to be able to see it. All right. There we have it. All right, one more problem. What's different about this one, you guys?
F of x and g of x. There's no y function.
Exponents are bigger. What else?
There's no y. There's no y.
Close.
There's no. Oh, I gave you actual functions. Good.
Yeah.
And what do you mean is closed?
It doesn't have the interval.
That's the main one I want you to notice. On this one, I didn't tell you where to stop and start. So this one, you do need to find your points of intersection again. But you're going to find they intersect at more than one point. All right? So let's go ahead and do it. We'll just kind of walk. Oh, this is student practice. So let's have you guys go ahead and go as far as you can with it. And then if you have questions, we'll see what you guys got. Huh?
He's just really excited to do it by hand.
Did I say it by hand?
No, he asked you to do it by hand.
Could you do it by hand? I don't know. Yeah, trying to get you guys to so first of all, guys, we graph it, and it's not. Shh, quiet, please. I'm not going to make a perfect graph, but it looks something like this, right?
That's
All
a
right.
perfect representation.
So now, as you guys know, since we're using a calculator, I don't need to find each region separately. But here are the 3 regions that we're trying to find the area of and combine them. But I can just go from beginning to end using one integral with an absolute value. So Thomas, what were our limits of integration? In other words, what was the first point and the second point?
The initial was -3.079, and then the final was 2.958. I rounded it.
Like that?
Yeah.
Okay, thank you. All right, and then from there, what we're going to put, it doesn't really matter which one you put first, because we're taking the absolute value anyway. But I shall ask Nicholas De Rosario, what did we get as a final answer there?
54.711.
There you go.
711. Add 0.2 to that. You get push.